Alright guys, welcome back. This is the second part of the video on factoring GCFs using the factor tree. In this video, we're going to talk about how to factor greatest common factors that have variables in them sometimes. So in the last video, we talked about factoring greatest common factors that only had numbers. This time we're going to see what happens when sometimes the GCF will have letters in it that we have to take out, and it really doesn't change too much. Again, not the fastest method, but this is good if you struggle a little bit with mental math. This method can be helpful for people. It just does get a little bit tedious, you'll see, on problems like this. So there is a faster way that you'll see in an upcoming video. But anyway, if we start, we've got 4x squared plus 8x. We're going to go through that factor tree method we did in the previous video. So we're going to go ahead and split up 4 into 2 times 2. And we'll split up 8 into 4 times 2. And then the 4 will split up into 2 times 2. So if we write this all down, 4x squared could be written as 2 times 2 times, so the x squared can be written as x times x. We'll put a plus sign in the middle, separating the terms. And then the 8x could be written as, we know that this is 2 times 2 times 2, since we had 3 2's in here at the bottom of the factor tree. And then we just have a single x here left over on this one. So looking at things to kind of circle here, I see that they both have actually 2 2's in common. So that could actually be written as a 4 on the outside. And actually, if you look, they don't just have numbers in common. This time they also have an x in common. So what we can do now is, instead of just pulling a 4 out, we always want to pull out as much as possible. In this case, we're pulling out a 4x. And then if we leave this stuff in the parentheses, the stuff that didn't get taken out is an x on this first term, and then a 2 on the second term. So we'll have x plus 2 as the leftover piece. And now we can kind of circle this as this should be our answer. Let's just double check it by distributing. So if we take the 4x into x, that would give us 4x to the second if we add the exponents there with the little invisible ones. And if we take the 4x times the 2, that'll give us 8x. Oh yeah, that checks out because that's what we started with. You should also see that there's nothing else that will come out of these two that they have in common. No numbers that go into both, no variables other than 1, of course, for the numbers. Okay. That takes care of our first example. Let's try the next one. It's going to be a little bit more tedious, but again, we can do it this way if we have to, but there will be a faster way, I think, for these problems in an upcoming video. So let's start here with the numbers. So we can split up 22 into 2 times 11. And 11 won't really split up except into 11 times 1, so I'm not going to really do anything with that. So if we write this out, we're going to get 2 times 11. Now here's where it gets a little tedious. We've got 5 x's to write out here. So it's going to be 1, 2, 3, 4, 5 x's, x times x times x, 5 times. And then the 11 here, there's no numbers to split up, but we'll write this as 11, and then 3 x's, x times x times x times y. And now we're going to have to start to look for what these things have in common between the plus sign here. So in our first term, we can see that it has an 11 that matches the second term's 11. So we'll put an 11 out front. So that would be good for the numbers that are going to factor out. But remember, whoops, I don't want to add that parentheses just yet. We'll leave a little bit of space because we're going to probably need some letters out here too. I can see they also have 3 x's in common. So 1, 2, 3 x's here, all the x's over here. So that'll give us an x cubed. Now they don't have, even though there's a y over on this one right here, in the second term, there are no y's in the first one, so we can't actually take a y out. So now we're ready to try to write our final answer. So the leftover pieces here that I can see, we had a 2 and 2 x's, so that's a 2x squared. And then on the second term, the only thing left here was a y. So I'm going to put a plus y here. And we'll circle this. This should be our final answer, but let's just double check this by distributing. So if I distribute 11x cubed times 2x squared, I should get 22x to the 5th if we add the exponents. And then on the second one, we would get plus 11x cubed, and then the y would just get kind of tacked on there at the end. Again, like we said in the last video, if you're doing a GCF problem and the original problem has 1, 2 terms, you should see 1, 2 terms left in the parentheses on these two things. So again, we started here with 1, 2 terms. We can see 1, 2 terms left in the parentheses after we took the GCF out. So that'll help us on the next one because the next one actually has 3 terms. So when we factor a GCF out of this last problem, we should see 3 we should see 3 terms on the inside of the parentheses as well. So we're going to start by splitting things up like we have been. I'll start with this 6x cubed. I'm going to bring this over here a little bit so I don't run out of space. So 6 we can split up into 3 times 2. And then x cubed we could write as x times x times x. We'll go to our 4 here next. So 4 could be split up into 2 times 2. We've got an x squared there, which is going to give us 2 x's. Put a little plus sign here in the middle. And then our last one here is just 2x. You can't really split that up, so we're just going to leave that as 2x. And now let's look for the different things we have in common. So I see here on this one, they all have a 2. So here's where we have to be real careful. I have to look for the things that every single one of these 3 have in common. So these 1, 2, 3 terms all need the things that I'm highlighting. So I see that they all have a 2. So let's start there. So what I'm going to do is write down in my answer, I'm going to put a 2. I'm going to leave some space kind of outside the parentheses. Actually, I got to leave a little more space out front here. Did that again. And then we're going to try to see what variables they have in common. And again, all 3 of them need the variable. So I see that this one has an x, this one has an x, and this one also has an x. So we could put an x out here. But they actually only have one x that they all have in common, because now this last term at the end is out of x's. So that's about it. So now if we're writing our final answer to see what's left in the parentheses, we're going to have a 3 with an x times an x. That's going to be 3x squared. Over here, we've got this little 2 here in the middle and this x here at the end that are left over. So we're going to put a plus 2x. And now be careful on the last one. Remember that in the original problem, we had 1, 2, 3 terms. So we need something in this space to take care of that fact that we had something there. So we said in the last video that if we ever highlight or circle everything on one of the terms, there's always an invisible times 1 here that's going to hold the place of that term that was left over. So that would be our answer here. I'll leave it to you guys to check with the distributive property if that actually equals the same thing that we started with. But again, that would be an introduction for how to factor greatest common factors using variables now that are coming out using the factor tree method. Stay tuned if you want to keep watching. There is a shortcut method that we'll talk about here in the future, but this is kind of the introductory method that I show people so they can see what's kind of going on behind the scenes before they get to a little bit trickier method that we'll get to.